Welcome to another exercise in the workbook Statistics. This time I'm going to focus on the normal distribution. Let's have a look at this exercise. Here we have a producer of canned foods fills his cans with ravioli. He uses a machine that is calibrated to fill the cans, stated filling quantity of 800 grams, with an average filling quantity of 810 grams. The manufacturer of the machine states that the machine works with normally filling quantities and a variance in filling quantities of 23 grams squared. Then our first task is, what is the probability that a random can does not contain the stated filling quantity? Second, at most the can is allowed to contain 821 grams, so that it can still be sealed without problems. What is the probability that a can cannot be correctly sealed? And finally, a charge contains 250,000 cans. How many of these cans can be expected to not fulfill the stated filling quantity? Well, since it says obviously here it's normally distributed, we're going to use the normal distribution. So let's start with the first one. Here we're talking about not fulfilling the stated filling quantity, so meaning filling quantity should be below 800 grams. We also know from the exercise our mean, which is 810 grams, and we have a variance of 23. So if we want to actually get the standard deviation, which we need in the next step, we're going to take the square root of 23. That's this. Then we actually have everything we need, because then we can simply, first off, normalize the 800 by subtracting the mean and dividing by the standard deviation, giving us a value of minus 2.09. Well, usually the tables which we use to look up the normal distribution, the standard normal distribution, only start at 0. So what we need here is first to get rid of this minus. We can get rid of the minus by placing a 1 minus in front of the big phi. So if we do this, instead of minus 2.09, we go with 1 minus phi of 2.09. This 2.09 we look up in our table. There we find a value of 0.9817. We're going to subtract this from 1, get a result of 1.83%. So the chance that one of the cans does not fulfill the stated filling quantity is roughly 1.83%. That was already our first part of the exercise. So let's directly go on with the next part. Here the question was more or less in the opposite direction. What's the probability that one of those cans actually contains more than 821 grams? Well, whenever we have something with greater than, we first have to turn this sign around, and we're going to do this by going to get our counter probability, which is just 1 minus. So x larger than 821, that's the same as 1 minus p of x smaller or equal to 821. Here we do not have to take care whether we use greater than, smaller than, or smaller or equal to, because this is a continuous distribution. Well, if we use this, we have here the first value. Again, from the exercise, we have the mean and the variance, and we can get the standard deviation. Then we can simply put this into the formula. We can standardize the 821 by subtracting the mean, dividing by the standard deviation, giving us as a result 1 minus phi of 2.29. The 2.29 we can look up in our table, finding there a value of 0.989, so that as a final result we get 1.1%. So the chance that one of the cans cannot be filled correctly is about 1.1%. Well, that's already part 2. So go ahead with part 3, with part C. And in C, we have more, well, on the one hand, a probability which we need. So that's how many of our cans do not fulfill the filling quantity. So first off, we need to have the probability of not fulfilling the filling quantity. Well, we already know this from part A, so we can simply copy paste this one. Then we have to multiply this probability with the total of 250,000 cans filled. So if we do this, we get as a result 45,750. So that's the amount of cans which contain less than the stated filling quantity. Well, that's everything there is to this exercise. So I hope you enjoyed it. I say goodbye and see you next time.